So a quick little aside, someone asked for some help setting up this template that I have, and so I saw it was a little bit of a pain, so I went ahead and I updated this, which is a new repo. You should be able to just clone it and go ahead and get this working if you want to use this. But yeah, there's still a couple like changes I'm still tweaking because I'm using this for the first time. But overall, this should be like a pretty good thing if anyone wants to start using this. Other than that, so today's day, I'm going to be honest, it kind of rubbed me a little bit in the wrong way. Nothing like wrong, but basically I ended up like getting a solution that worked pretty nicely and fast, but it does make a lot of assumptions that don't actually like they're not safe assumptions. There's like for a lot of inputs, they wouldn't make sense. And it looks like I looked on the Reddit after I solved it, and pretty much everyone had to make those same assumptions. Otherwise, the question gets a lot more of a pain to do. Not impossible, but still a huge pain. So, but without that, let's go ahead and start coding this. So basically, this is a little bit of like a little kind of, not really a graph search, but we have a little bit of a network here. Basically, each of these is a node, and this is our left and our right path. And we basically just keep following this input until we end. So let's first of all just go ahead and parse this input. So what we're going to do is instruction. I'm going to call this instruct, and nodes is going to be equal to our input, and we will split it on two new lines. So if I go ahead and print this out, just as a little sanity check, and I run this on the test cases, and I have 3 test cases right now, because if you get to part 2, you'll get there. But here you can see we basically split this up, and we have, since we're splitting with a comma, it's just printing a space between it, but you can see here is instruction, and the rest is nodes. Perfect. So let's go ahead and deal with our instruction first. And maybe it'll make a little bit more sense how I handle this, and I think I do this in a nice way after I kind of parse through nodes. So we'll do, I'll create a function or a map called network. It'll be a dictionary. And so for each line in nodes.split lines, because remember this is just a huge string of the lines. And if I just print this, just a little sanity check again, we can see we're getting all these lines here. So what I'm going to do is I'm going to go ahead and use regex, which a lot of people don't like, but it is pretty nice once you get to use it. And so what I'm going to do here is I'm going to do source, left, and right. And I'm now going to parse out basically all of these little like string chunks where we can see it's like a name where it's like this. And also if you look down later, eventually we will get numbers in it. So we'll get to that there in a second. But here we'll do re.findAll like we did last time. And I'm going to do R here for like a kind of literal. And then we're going to capture basically any capital letter, and it can be 1 or more times. And we want to read this from our line. If I print out now source, left, and right, let's see what we get. Boom. Here you can see, oh, I scrolled too far. Here you can see we're basically printing out just exactly what we want. So A, B, C. If you look here, this first line, we basically strip all of these and we get it nice unpacked into the variables. Perfect. And now all we need to do is we'll do net source is equal to a tuple of left and right. And so the nice thing is now I can basically just index into this with like a 0 or a 1 if I want to get the left or the right. And so now I'm going to go ahead and parse the instruction. And so I'm going to create a function, and I'm going to call it loop. That's going to take in some instruction. Now I'll turn this into its kind of 0 and 1 notation so that I can just feed it nicely into this. And you'll see why in a little bit. But here, I'm going to overwrite the variable because it's fine. If instruction is equal to left, else 1 for instruction. So for each instruction, if it's a left, I'll set the variable as 0. Otherwise, set it as a 1. And so now I get this as a little list. The nice thing is since these are 0s and 1s, I'll just be able to go directly and just put it into like whatever is in here. And then it'll just give me the left or the right one. So now the question is, how can we loop this forever? So what I'm going to do is I'm going to use a function called yield from. So first of all, if I just do yield, this is basically how like things like Python ranges work. So if you ever wonder how it's like for I in range 10, what this is basically doing is it's yielding from some iterator, and then basically it's only giving you the value once you try to access it. That way it doesn't calculate everything at once. So I'm going to do yield from, which is basically going to keep returning things one by one from this object. And then I'm going to do this in a while true loop. So basically just, this is going to always keep yielding me the next value. So if I go ahead and actually just show you like a little example, for I in a loop instruction, print I, this is basically just going to keep printing 0s and 1s forever for the first example. And you can see like this. What this is basically doing, if I walk through this, is when I pass in the first input, which is this R and L, going to turn it into a list, which is 1 and then a 0. And then here, when I first basically do for I in this, when I ask it for an object, it's going to give me first the 1 from the R. Then I ask it again on the second loop, and it's going to give me the L from the R, L. And then this while true is going to happen, and it's going to call yield from again. And it's basically just going to keep returning this. And this is called the generator if you want to look more into it. But so now, basically, we have a way of infinitely kind of looking over our loop. And so for part 1, what we want to do is we want to start off at 3 A's, and we want to eventually get to something that's ZZZ. And we need to tell how many steps it takes. So I'm going to do answer is going to be equal to 0. And we're just going to keep going over instructions, and our position is going to be equal to AAA. And then if position is equal to ZZZ, then we'll return our answer. This will be like your time. And then otherwise, we're going to do answer plus equals 1 in position. And this is how we're going to kind of make our move. We're going to do net at position. So see basically the moves at our current position, and then take either left or right based on whatever instruction we're currently on. And then finally, I'll go ahead and return this and see what we get. So if I run this for the test case, oh, it does not like that. Let's go ahead and see why it's complaining. I'm returning answer. Answer is 0, 0. Oh, sorry. This should not be returning answer. This should just break, because I want to break out of this loop. And then our answer is eventually getting returned here. Cool. So ignore this exception for now, but we'll see here our test cases are 2 and a 6. And if I look at the code, it says this should be a 2, and down here, this should be a 6. It says here. So my answer is this. If I go ahead and now submit my code, we get the right answer. Cool. So now time for part 2. So part 2, first of all, first thing out of the case is this test case that they give us is a little bit of a pain because we don't have an AAA. And we also don't have a ZZZ, so we can't hardcode those values anymore. And the weird thing is, in our actual input, we do have those values, because if I look for it, AAA is right here and ZZZ is right here. It's just this test case. So we're going to have a little bit more of a hacky code, but I'm going to go ahead and create a function called solve, and it's going to take in instruction net, our network, and like a start node. And I'm actually just going to call this position, just so we don't have to really reassign a new variable. What I'm going to do from here is I'm going to move all of this code that we have, and I'm going to move it into this function. And it'll make sense in a little bit, hopefully. But now I can just go ahead and change this to solve instruction net and then AAA. And if I call this, still looks like it works fine. 2, 6, this is fine, it's an exception. And if I call it on my input, we're getting the right answer. The reason why we're getting this exception also is if I look here, there is no AAA. And so we can see the error that we're getting is a key error, because it's looking into net for AAA and it's not there. So what we're going to do is we're just going to manually hardcode that out. So, oh, and we should get rid of this line. If pause is equal to we'll do if pause is not in net, we'll return just a string error. Oh, sorry, too much English here. Now it just prints out error like this. And we'll make this uppercase, just to make it a little fancy. So now we go ahead and test again. All this code works and we're getting the right answer. So for part 2, the thing I kind of don't like is there's a lot of different ways this question could go. Like for example, what happens if we eventually get to some point and the Z starts looping? Or there could be several different answers, as in they're saying any kind of end state could end with a Z. And so it could be something where it's like, maybe you go from 111 or 11A to 11Z to something else, and you eventually get back to like 22Z, and then you go back to 11Z, and you could get some weird things. But the problem is, I went ahead, my first iteration, I just tried kind of coding this, and I tried doing, kept updating all of these things, and it ended up not working. This is my answer. This is like roughly the range of your answer to, oh, sorry, I'm not showing it. This is roughly the range of your answer to, and so this is going to take forever to run on your computer. And I didn't like that, so I started looking at a couple other things. So first of all, one thing that happens in previous years is the big thing is cycle detection. So what my thought was is maybe if there's some way of detecting a cycle, as in, and like this is something that you can actually prove pretty nicely. So I have a finite number of states here. So for example, here, let's just say I have 8 states. I can guarantee you that eventually you will hit some cycle, because if I choose any state and I run for 9 times, if I didn't have a cycle, I would have to be at 9 different states. But I only have 8 states, meaning eventually everything will cycle. So based on that, I can just find the period of the cycle. And so for example, if my first 1,1a, like we can see here in this example, 1,1a hits its first solution here at time 2, and it hits another solution at time 4, and hits another solution at time 6. And so we can see every 2 steps, so at t, whenever it's divisible by 2, we get a solution. And then for T2a, you can see every 3 steps it gets a solution. And so the period to get a solution for the first one would be 2, and the period for the second one would be 3. And we'll find the lowest common multiple of these, which in this case would be 6, and that would be your answer. That would be your time step. So first of all, in our code, we already kind of do this. So this solve is telling us when we get our first solution. And also, the thing I kind of didn't like is you have to make the assumption, at least for the code to kind of work nicely and cleanly, quickly. You make the assumption that, first of all, like from your start time to your first solution, that's your period. But it could fully be the case. Like, for example, if instead of 1,1a, I made like a new state like 0,0a, and I fed it into 1,1a. It would get its first solution at time 3 because it takes that one extra step to get here, and then from there it would loop every 2 times. That could have been the case, but in this question it looks like for everyone it was not the case, meaning it cycles exactly at whatever the time of your first solution is. And you also, someone did point out here, I think they pointed out, yeah, number of names ending with A is equal to the number of names ending in Z. This is kind of because when I looked through my code and I looked at my own example, every input, like everything that ends with an A, has exactly one unique output, one that ends with a Z. And so with all of these assumptions, what we can do is we can basically just find whenever each letter hits its first solution, write that down, and then find the LCM of those. So let's go ahead and do that. So first of all, let's import from math, import LCM, which is really nice. This only exists in Python 3.8 or 3.9 or above, I believe, fair warning. But so now what we can do is we'll do periods is equal to an empty list. And then for node in network. But the problem here is we only want to see the ones that start with A's. So this isn't the cleanest way to do it, but I'm just going to show something new. I can call filter, and filter basically only will return things where I can pass in a function and some iterable, and it'll only give me out the things that pass this function where it returns true. So I'm going to use a lambda, which is basically like a impromptu function that takes one parameter, and it should return if whatever parameter, I take the last thing in it and see if it's equal to an A. So let me just run through this line. This right here is a little function. This is the same as if I did def some name x and return x is equal to A. These are basically the exact same thing. Lambda is just a little shorthand syntax where I can put this in one line like this. It's an anonymous function. If you want to find more information, just Google Python lambdas. And then I'm calling filter, which is basically calling this on every element in network. If that's true, it lets me use it, like it returns this out in a list. So now if I go ahead and just show this, and I'll run this on just my input. Oh, sorry. This is called net. And then also another thing is if we look at this example here, these have numbers in it. So just to make our code kind of allow for this, we're going to now add in reading the numbers 0 through 9 when we're parsing. So now if I do this, these are all of the inputs that we're taking. So let's go ahead and add all of their periods to this period list. So periods.append, and we'll do solve, and we'll pass in our variables we need to, and then whatever our node is, and print out periods. If I go ahead and run this, something does not look right. Oh, it's because we're looking if it ends with this one, but we want to make sure that it's ending with just a Z. So because we kind of know through trial and error that every input has exactly one output, like if I pass an AAA for part 1, it'll end with ZZZ for sure. So we'll go ahead and do this for the new condition. So if you end up at a solution, then just break. So now if we see this, we get all of these as our periods. As you can see here for AAA, which was our first input, we're getting the same thing we got for part 1. And so just sanity check, same value here. So we didn't break anything. But so now we just need to find the LCM of all of these. So I can call it LCM, and I can pass in all of these as arguments by doing this. This is basically just unpacking. So basically, instead of this being an entire list, I'm spreading it out across all the elements, kind of like if I did this for all of the elements, so forth. And so this is a nice little syntax trigger. But if I go ahead and call this now, I get the right answer. So overall, in summation, this day, I kind of didn't like it, left a little bit of a sour taste in my mouth because we had to make a lot of assumptions that weren't necessarily true. But this ends up working pretty fast. It only takes 44 milliseconds on my computer. And yeah, hopefully it was good.